In this video, we'll be seeing how to use the binomial distribution. Now, we're told that a factory produces bolts with a 1 in 50 chance of any one bolt being faulty. And we're then asked, what is the probability of there being exactly 5 faulty bolts if the factory produces 200 of them? Well, in this case, we can definitely use the binomial distribution. And just to remind ourselves of what the formula for that was, we saw that the probability of the random variable being equal to r is equal to the binomial coefficient nr times the probability of a success to the power of r times 1 minus p to the power of n minus r. Now, looking at this, hopefully it's quite clear here that we have to figure out what n is, what r is, and what p is. Now, luckily for us, though, all of these are given to us in this question. We're told that there's a 1 in 50 chance of any one bolt being faulty, and we're told this in the very first sentence. This tells us that p is equal to 1 in 50, which is the same thing as 0.02. In the same way, we're being asked to find the probability of there being exactly 5 faulty bolts. That's here. That means that we're looking for r is equal to 5. Finally, we're told that there are 200 of them being produced. So that corresponds to the number of trials here. In other words, n is equal to 200. Using all this, we can now go ahead and say that the probability of x being equal to 5 is equal to the binomial coefficient, 205, times 0.02 to the power of 5 times 0.98 to the power of 200 minus 5. Simplifying that last term a bit, that leads us to 205 times 0.02 to the power of 5 times 0.98 to the power of 195. Now, for this binomial coefficient here, that 205, we would of course do this with the calculator. And using our calculator, I'll just write this in a different color here. Using the calculator, for 205, we find the following. It's 2,535,650,040. Sorry, 650,040. Now, we now calculate all of those. We have all the numbers that we need to calculate this. And with the calculator, we find that the probability of x being equal to 5 is equal to 0.15787, and there are some more decimals after that. So to 3 significant figures, the probability of x being equal to 5 is equal to 0.158. And that's to 3 significant figures. So we could actually say that the probability of there being 5 faulty bolts is approximately equal to 16%. And there you go. We've just solved this question using the binomial distribution.